beautifulness. All of this. Under the shore. And hopefully I'm in the right area. This is beautiful. We'll be able to record this when I come back out. So, it says gift shopping tickets. Alright, 1 second. Hello, how's it going? Good. If I'm showing, I want to buy a ticket. This place where I can buy a ticket.
Yeah.
Okay, cool.
I'm trying to buy a ticket for...
I think it's Exploding Universe? Yeah.
That show is actually canceled.
What?
Yeah, I'm sorry about that. We're having a problem with our projector right now.
Wow. What's playing next?
It's a Laserdome show for Taylor Swift.
What time is that?
It's at 6 o'clock.
Okay, that was not gonna be canceled.
No.
I know they play like her hits or her music. And then they just show like a laser show.
Yes.
Do you know, have you seen it before?
I haven't seen it.
Do you know like what it entails as far as like laser showing?
I'm not sure. I can ask my manager.
Okay, cool. Yeah, thanks. Cancel the show, y'all, but bear with me. It's crazy. See what's up. Hold on real quick. I'm coming back.
So it's literally just lasers and music, and then sometimes the lasers will show like stories.
Stories are just like the universe, or
I believe about the music or about the artist. I'm not sure.
so it's gonna really be focused on the artist there.
Yeah.
This part. Dang, that's crazy. Does you guys show normally cancel depending on
No, it was just for today because our projector just randomly stopped working.
That's crazy.
Yeah.
Okay, what time you guys closing here?
Today we close at 6 today. After the show, the Taylor Swift show.
Okay. And then I can buy the ticket between now
and 6 o'clock.
6 o'clock. Okay, cool. Is this like the whole shopping area here? I'll just take a look around and then make a decision. Alright, cool. And what is it like? How much? $10 or something?
It's $17 for general public, and student is $10.
Okay, cool. Alright, cool.
Thank you.
So it's crazy. We came all the way down here. But we gotta make something out of this. Okay, cool. So still here at the planetarium. So let's see. It's kind of cool. Let's see. Orange Coast College Planetarium. Follow us on Instagram. You can follow them on Instagram. Check out some cool things. OCC Planetarium. Calendar of events. Yeah. Okay. Sign up for our newsletter. Okay, you can sign up for the newsletter. Okay. Hey, it happens, you know what I'm saying? It's a part of the experiences of being an influencer, creating content and all that. How did our solar system form? Meteorites hold clues to the origins of our solar system. Okay. Alright. We'll get us some content today. All about asteroids. Most meteorites come from shattered asteroids. You can kind of see what we got going on here. Located between Mars and Jupiter, the asteroid belt holds millions of asteroids all orbiting the sun. It creates a boundary between the rocky inner planets and the ice and gas-rich outer planets. Occasionally, an asteroid falls from its orbit and begins flying toward the sun. Alright. Most asteroids are tiny, about the size of a pebble. A few larger ones have been named. Vesta is the brightest asteroid often visible from Earth with the low-powered telescope and sometimes the naked eye. Although Vesta is only 325 miles in diameter, it resembles the inner planets with a rocky outer crust and iron and nickel core. When Vesta was first discovered in 1807, it was considered the fourth planet. Alright, so we got that here. Okay, probably what I should have did here. Saw this and got a chance to zoom in on this. Okay. Stony news. Did you know the stony meteorite you see here came from asteroid Vesta? Asteroids in the inner planets Mercury, Venus, Earth, and Mars formed close to the Sun. Here, intense heat caused rocky and metallic minerals to condense. Over time, the heavier bits collided and stuck together. Metallic elements were pulled into a center core, and lighter silicate materials floated to the top. Here we are. Things floating to the top, I assume, or exploding. Looks like achondrite. Stony meteorites show silicate materials that are also found in Earth's mantle and crust. Alright. Over here, okay. What do meteorites tell us about the planets made of metal and rock? Meteorites resemble the four inner planets. We got some images here. Okay. If you're excited about planets, this is a really cool place to come to. Let's do some more reading. Planetary layers. Meteorites help us understand Earth's geology. We got here Mercury, Venus, Earth, and Mars formed close to the Sun as bits of rocky and metallic material smashed into each other to create larger bodies. Farther from the Sun, a similar process happened for the outer planets, but with ice and gas particles. There you go. Let's see what we got going on here. Alright, let's move down here. Our Earth holds layers, a metal inner core and a rocky outer mantle and crust. In the molten heat of collision that formed the Earth, dense metallic materials sank to the center. Though we can't look inside the Earth's core, we can study iron meteorites to discover its composition. Alright, we got the crust there. Okay, we kind of see that a little bit more mantle inside there. Outer core, looks like we're getting a little to the heat there. The inner core, we're definitely inside of that heat. Alright. And iron inside. Did you know iron meteorites are more than 98% metal? Primarily made of iron and nickel, they contain cross-hatching metal crystals in a Widmanstatten pattern. We can see this pattern clearly when a meteorite is polished and etched with nitric acid. Iron meteorites come from the dense metallic interiors of larger asteroids. Okay, got an image here. Alright. The Earth's core is mostly molten iron and extremely hot. If cooled, would a piece of its core resemble an iron meteorite? For us to find out. Alright. I got some cool things here. Okay. Alright, got a chance to see some of this here. Alright, let you guys take that in. see if I can zoom in on. Okay, we got some here. Okay, so for this rock here, okay, so let's see if we can get some of these words right. Breccia meteorites like these are made up of lots of individual rocks brought together through gravitational or electrostatic attraction. These lighter rocks float to the surface of differentiated asteroids, much like the Earth's crust. Okay. And then the cross-hatching pattern visible in this iron meteorite is called a Wittgenstein structure. Okay, we talked about that over there, which formed more than 4.5 billion years ago as the metal cooled. These patterns only occur in very slow cooling metals, like those found in the core of a planet or asteroid. In fact, they require such slow cooling that they are not found in any of the rocks on Earth's surface, as scientists can't even recreate it in a laboratory. Wow, it's pretty cool to know. All right, let's see if I can zoom out of this. Okay, what we got here? A piece of the red planet. Martian meteorites map to the planet's geology. Okay, let's see what we got here. Barren and dusty, the landscape of Mars looks a little like Earth's deserts. But billions of years ago, the planet was alive with flowing water and active volcanoes. Today, Mars rovers travel the red planet, helping us study its surface and atmosphere. Meteorites also provide clues to its geology. Okay, so let's travel over here. It's crazy as I was reading that, we're so familiar with volcanoes. Just knowing about volcanoes. But it's like when you think about so many, thousands of years ago, year 2024, but how far time has gone back before us, it's like, imagining how Earth really started, because you have, religion, you have all types of information out there that gives us the so-called truth, okay? But there's no buts. But adding to that, when you think about some of the animals that resemble dinosaurs, we have these fossils and things like that show that there were these oversized large animals that lived here on Earth. It's hard not to believe that we really did have dinosaurs, and going to volcanoes, it's like, wow, volcanoes that still exist. It's like when you think about the planets and how, the galaxies and all of these meteorites and explosions and, hot gases and all of these cool things, scientific things that took a lot more disastrous existence back then, it's still kind of here, right? And so, just reading that, when I got to the volcano part, it was just like, man, we still have that here. That's crazy. Like, and it just kind of gives you that more of a faith in some of the other ideologies or ideals of how Earth was, or how we got here in the first place. So anyhow, Food for thought. All right, so let's go here. Martian meteorites have a basalt composition dating to about 1.3 billion years ago. At this time, massive volcanoes near the planet's equator created piles of basaltic rock up to 11 miles high. Martian meteorites also show evidence of water and carbon-based compounds. It's possible that Mars once had oceans and forms of organic life. That's crazy. That's crazy. Just learning about this stuff if you are not like, fully educated in these things. We grew up, through school learning about it, but if, you're not super into it, you may just have a basic foundation on, these things, and then you watch movies and, we play around with, aliens and Mars and, life outside of Earth and things like that. But then you read things like this and it's just like, wait, hold on. Like, you hear what they saying? Like, that's crazy, Anyhow, it's kind of cool. Space rocks, meteorites. Small rocks from space till big. Sorry, I'm reading from my camera now, so let me read it on the platform. Small rocks from space tell big stories about our solar system. Okay, cool. Let's be here. All right, meteorites are space rocks that have fallen to Earth, traveling at high speeds through our atmosphere. They burn up as meteors before shattering into fragments. But even the smallest fragment tells a dramatic story. Meteorites hold clues to the birth of our solar system. They help us understand our neighbors orbiting the sun, including other planets and asteroids. Okay? What can you learn from meteorites? Explore the gallery to find out. Okay? So, whether that's online, coming here, or some planetarium. Okay? All right. Ancient time capsules. Meteorites contain the first materials to form in our solar system. About 4.6 billion years ago, our solar system began as a loose cloud of gas and dust after a giant shockwave, which may have been caused by a nearby exploding star. The dust cloud collapsed. Tiny particles of dust began swirling around a flat, spinning disk that eventually became the sun. That's crazy. Okay. Intense heat and pressure melted the dust particles into tiny spheres that scientists call chondrules over time. Over time, the chondrule particles clumped together to form larger asteroids and eventually the rocky planets. In the most ancient meteorites, we can see chondrules clearly under the microscope. Okay, so here we are here. They got that as clear as they could have it. So you can see how they, are throwing that in. I don't know what that means, but I thought it would be cool to show. All right, solar nodes. Did you know scientists use meteorites to date our solar system? Our corner of the universe began when a massive gas and dust cloud collapsed on itself and started to spin. At the center of the spinning disk, a young star, our sun, radiated intense heat. The very first rocks formed as materials condensed around it. Okay, so, all right, man, it's crazy. These ancient chondrite meteorites, like the one here, contain calcium and aluminum particles from billions of years ago. Scientists use them to determine the age of our solar system. Man, this is just so cool. This is really getting me back into these, the passion of the galaxies and, space science. Okay. Where do meteorites come from? Meteorites break off from larger space rocks called asteroids. Look at that. Let me show you something. Look at that. That's crazy. I know. Alright, we're going to have to try to get up in here how we can. A piece of the moon. Some meteorites fall to Earth from our orbiting moon. Unlike Earth, the moon has a thin atmosphere. Meteoroids are constantly colliding with its surface and leaving craters behind. Without wind or rain to sweep the craters away, they stay visible forever. The moon's thousands of craters show impacts from millions of years ago. Okay. That's what they're showing us here. Okay. Let's see what we got here. Lunar meteorites are rocks broken off during these collisions. After traveling through Earth's atmosphere, their exterior takes on a melted or fusion crust. This makes them look a little different than the moon rocks collected by astronauts, such as those taken during the Apollo 11 landing. That was a cool movie. I think I watched that. Check it out if you haven't. Here we are here. Okay, let's see here. Breaking moon news. Did you know the moon is about 4.51 billion years old? Just a little younger than the Earth. Wow, just a little younger than the Earth. That's crazy. It's likely the moon formed after a collision between a proto-planet Earth and another planet about the size of Mars, which scientists call Theia. I hope I said that right. The collision caused both planetary bodies to melt and reform as one planet, the Earth. Debris then collected in Earth's orbit to form the moon. Wow. Debris, huh? That's crazy. Okay. Alright, what we got here? Are we made of stardust? Most of the elements in our bodies are found in meteorites. You got this little girl looking up, okay? We have these elements in our bodies, apparently, okay? Alright, what else do we have here? Meteorites and us. Meteorites hold clues to life's origins. Let's step a little closer. Scientists study meteorites to learn about other rocky bodies in space, including asteroids and the inner planets. But meteorites may also hold clues to the building blocks of life. Researchers have found organic molecules, complex amino acids, and even biological sugars inside the most ancient meteorites. Okay, so here we go. Alright, let's see what we got here. In 2000, a large meteoroid scattered fragments over a frozen lake in British Columbia, Canada. Under the microscope, these fragments showed the same left-handed amino acid pattern characteristic of life on Earth. Did asteroids and meteoroids falling to early Earth bring the building blocks of life? Scientists don't know the answer, but it's clear that space rocks hold mysteries worth studying. Okay, see them kind of studying that there. Alright, let's see what we got here. Meteorite beauties. Did you know Palisade meteorites sparkle like gems when the light shines through them? Okay, there's that. It's kind of cool. Palisade meteorites. Okay, let's see what we got here. Pallasites are rare, with only 61 known to date. These stony iron meteorites contain a mixture of olive green silicate embedded in metal. Their composition is similar to both layers of Earth's geology. And iron and nickel core covered by a rocky mantle and crust. Alright. What's a shooting star? Alright, well, kind of see those there. Traveling at high speeds through our atmosphere, meteoroids leave behind trails called shooting stars. Alright. Alright. Impact craters. We talking about y'all, so come on, craters. Large meteoroids can leave an impact. Well, leave an imprint. Okay. Alright, so let's start here. Before landing on Earth's surface, meteoroids travel at high speeds through our atmosphere. This makes them very hot. Most burn up as they fall toward Earth, but larger meteoroids leave an impact crater when they hit the ground. Okay, so that's what happens there. Okay, let's go here. Over 50,000 meteorites have been collected on Earth. Most fell without leaving a trace. Others left craters that wind, rain, ice, or lava eventually erased. However, some large meteoroids or even asteroids form craters we still see today. Scientists believe that the dinosaurs went extinct as the result of an asteroid hitting the Earth 65 million years ago. Now that's crazy. You know, I probably learned this stuff in middle school, high school, but, you know, I feel like I'm retaining it more now. You know, it's a lot more interesting now. I wasn't interested in it then, but just, like I said, just retaining it much more now. It's more interesting, I guess. Okay, crater talk. Did you know over 100 tons of small space particles hit the Earth each day? Most impacts are nothing to worry about. Scientists predict that a meteoroid the size of a football field may hit the Earth every 2,000 years or so. Wow, that's crazy. And there you have it, okay? That's crazy, all right? That's wild. I mean, can you imagine? No, I don't even want to, I ain't even going to finish the sentence. Okay, Arizona's Beringer crater was formed by a large impact occurring 50,000 years ago. This iron nickel meteoroid was about the length of 3 semi-trailers. Most of it exploded, but scientists have collected fragments like the one you see here. Okay, so, you know, I guess we have both of these messages to reflect on this picture with or for. Okay. And we passed up on this little gem here. Okay, got to look at, and let me see if I can zoom in on that rack and give it a little beauty. Walk around. Zoom back on. Like that. Okay, and so before I go reading everything, let me see. That's beautiful the way that's. Man, I know there's something scientific about that. Check this out. Look at that up there. Just like that. That's crazy. Beautiful, beautiful, beautiful. Okay. So I think it's just the same thing here. Let's see what we got going on here. So, I don't know if I'm saying this right. I believe the word is Foucault's pendulum. Okay, still providing the Earth's rotates. All right, let me see what we got here. Let me see if I can step a little closer. All right, let me see if I can. I'm gonna zoom in a little bit. Cross that there, and then I'm getting my read on. Did you notice the pendulum knocking down a pen? Okay, I don't think we have it knocking down pens yet. Okay, so let's see what they mean by that. Over time, the pendulum will strike each pen down one by one. Jean Foucault first demonstrated this in 1851 at the World's Fair in Paris, France. Wow. The pendulum swings along a fixed vertical plane while the pens are fixed to the earth underneath the pendulum below our feet. Okay. As the earth rotates, the pens are brought into the path of the pendulum's swing and knocked over. Okay. The time it takes for the pendulum to go in a complete circle depends on your latitude. Okay. At the North and South Poles, it takes 24 hours. Here in Costa Mesa, it takes about 43 hours and 15 minutes. Since the pendulum hits the pins on both sides of its swing, it only needs about 22 hours to knock them all down. Okay, so I'm gonna show you a little something. You can calculate the time at any latitude on Earth using this formula, okay? So, there you have time equals 24 hours over, I don't know if that's sine or sine of your latitude. Okay, so here's some information here where you can find out more, about all of this coolness of the Foucault's pendulum, okay? Now, what I want to show you is, look at this. It looks like it has already knocked down a number of the pendulum, okay, the pins. Okay, there's a north, west, okay, I'm sure that's south and east. But this is kind of cool because until reading that, I wouldn't have paid attention to the pins. And honestly, I just don't even know if I just don't know if I would have picked up on that. And it's crazy because it's like sitting here, would we be lucky enough to kind of see one knocked down? That's wild. This is just fascinating, man. I feel like I want to do this more, a little bit more. This is beautiful, man. I'm so glad I came here and done this. Blessings in disguise of things, because let me zoom back out. I'm sure I've been able to learn something cool on the inside, but also I got a chance to, speak and read and learn, and I feel like it can be a little bit more powerful and impactful when you are doing something that you're doing for your. It's not like I wasn't gonna do things for myself watching the movie on the inside, but sometimes it can hit a little different when you're researching and reading yourself on things that you're learning about. Okay, they had t-shirt. I'm saying. Okay. Tote bags were $15, t-shirts were $25. I'm sure if you're a student you can get a little discount. Socks over here. Okay. Okay. Got some socks over here. I'm not for sure how much they cost, but let's see what we got here. Oh, $11. Okay. And then we have, looks like, are these like some type of hairpins? Okay. I don't know what type of, notebooks. Okay. So I'm sure if it's like an address book or something. Buy some just cool souvenirs or whatever. Candles and coffee mugs. What else do we have? Looks like a puzzle there. That'll be kind of cool to get a book. We'll see. Space stars, the beginning of time. Yeah, we get a lot of cool books here, I'm sure. You know, a chance to. Oh wow. Other things to know about the oceans. The oceans would be. Oh man, that'll be cool. That's super cool. That'd be dope to kind of put into one of my self-care vlogs. Chasing Space. Come on now. Universe. I feel like I might have saw this book before. Okay. Cool alien little stuffed animals. Telescopes. Pretty cool too. Definitely for the kids here for sure. Other stuffed animals. If you're into these kind of things. Right. The globe. Globe is kind of cool. Right. That's it. Some cool alien things here. Cool little souvenirs. $5 or $2. $6.50. That's kind of cool. See? It's kind of cool. Kind of. Oh yeah, here. Oh, yeah. Not for sure what's happening right now, but maybe my afro is standing up. Okay, we got. Oh yeah, here. Oh, Lord, sweet. No, I don't even know if that's real or not, but no. $100. No, this stuff gotta be real. I mean, look at this. Yeah, Martian meteorites. Okay. Oh wow, that's kind of cool. $50 for that telescope. What can you see from this far? Well, it shows 50. That might be just the size of the telescope kit, but how far you can look up out there. There's some cool things here. See if I can zoom in there. I got a cool little thing back there, that little white fur thing. Cool. That one's bigger, that telescope. Pause. What's some cool things? If we can zoom in a little bit more. Says crystal. Growing. Okay. Those look kind of cool. Alright. See if I can zoom out. Relax. Okay. Did I zoom past this too quickly? Astronaut fruit? What? Astronaut fruit? What's so cool about this astronaut fruit? Is it like just dry fruit?
Yeah.
Okay. Okay, cool. Thanks. Gotta walk away with something, maybe. Oh, that's this here. Galaxy ball, that's kind of cool. Oh. Mars mine. Okay, kids will love that. Show you here. Look at that. This makes first manned landing. It's crazy. The second Apollo being prepared for walk on the lunar surface. That's crazy. I ain't gonna bore you guys with too much info. I've spoken a lot about it. What's to learn more about here? Show you here. Mary Lynn Bergman Morales, Planet Planetarium Theater. Man, we was almost up in here. Well, we can always find our way back up in here. You know what I'm saying? You know. How much time we got? We're gonna have to cut this video short. $25. I'm just gonna give this to you guys. You can pause this and read that. Okay, just for time's sake, you know what I'm saying? Pillars of Creation, you got Cosmic Cliffs, and the Carina Nebula. Okay, get a chance to pause this video and read that if you like. Okay. Alright. Just for time's sake purposes, okay? Now, get a chance to look at that. Small. Magellanic. I want to say I said that right. Clouds. Okay. And I'm gonna zoom in a little bit more on that for you guys. Push pause and read that. Phantom of the Universe. The Hunt for Dark Matter. Okay. That's probably some movie that you can watch here. Space Mission. Got that. UNC. Alright, UNC. Okay. Planetarium 102. Okay. So, we got a little office over here. This is cool. Jupiter movie. Okay, so you can kind of like, you probably can, watch a movie here. But again, like I said, stretching for time. Okay. You got Ocean Conveyor Belt. Okay. Alright. So, I don't know if you plug in. Well, you probably just play it. And, I don't know how weird it would tone out in this one. Whatever this was. But, yeah, I don't know if it'll play loud or not. But, anyhow, you got Winds. Geos 5 model. 2006. I don't know what that means. But, okay. And again, I'm sure you can play this and learn some things. Okay, so just double check for the one time. So, you know what I'm saying? Rocket shot glass. This one is crazy. It's crazy, this little alien. Let me flip back around. This little alien. Thanks, 25 cents. It's kind of cool though. Planetarium pen, hold on real quick. Oh, this is kind of cool. I think this is what your boy might get. Okay. That's kind of cool. NASA t-shirts and stuff. I said, so that's pretty much everything, you guys. And I think I might, kind of see this. Can't really see it, but anyhow, it's a planetarium pen. Okay. Actually, I think I had it upside down. Man, are we killing it? Here we go. Okay. What would be kind of cool is like, get one of these books. But yeah. Just make sure I'm not bypassing anything. Trying to see what fits me, you know what I'm saying? I feel like this pen fits me. You know what I'm saying? these little souvenirs.
And with card,
Probably with cash, yeah.
it will be $4.75.
Yeah.
$15.25. Would you like your receipt?
Sure, why not?
Here you are.
Cool, thank you.
Thank
Appreciate
you.
it. Maybe my luck will run for me next time.
Yeah, sorry about that.
No, that's okay. You said it doesn't really happen often, huh?
Yeah.
Yeah. Oh, maybe next time. Do they normally show the same film like that one occasionally? I know they probably have reoccurring.
Yeah, it's reoccurring, yes.
So that one is one of the reoccurring ones.
Yes.
Okay. Cool.
Thank you.
All right. You're welcome. Thanks again. Give me 1 second. Push pause. 1 second. Give me a second, real quick. Push pause. Actually. Alright, so not bad, not bad. I need a little second. I just want to figure out what I'm going to commit to today. Let me see. Space Rack. Let's see. Did I miss something over here? Did I miss? Oh, okay. I didn't have to hit that one. So I'm gonna sit here. Anyhow, yeah. This video is pretty long, so I'm trying to see. I started this video, yeah. Yeah, I think I'm gonna end it here, you guys. Thanks for tuning in. This is pretty cool. Like I said, you can come here and check out OCC's planetarium. Yeah, this is pretty cool. It wasn't too bad, you know. A little mix up of things, you know. Sometimes, you know, you have detours in life, but you know, you just try to, you know, make the best out of it. And I feel like we did. I feel like we made the best out of it. I'm still excited to be here and got some cool souvenirs. And I think that you know, we're just gonna keep this thing going as usual. Hopefully, you guys are motivated to remember that. Oh wait, man, let me see something. Science on sphere. Hold on, real quick. 1 second. Yeah, we gotta flip this around. Let's see, we gotta catch everything. We can't be missing nothing. You know what I'm saying? Science on the sphere. Alright, Science on the Sphere is a global display system developed by the National Oceanic and Atmospheric Administration for use in science centers, museums, and colleges and universities across the country. Using NOAA's collective experience and knowledge of the Earth's land, oceans, and atmosphere, SOS can present cutting-edge science to the world through visualizations that show information provided by satellites, ground observations, and computer models. SOS can present animated images of atmospheric storms, climate change, and ocean temperature. Additionally, SOS can present satellite pictures of the Earth, Moon, and other planets. SOS is presented on a 68-inch carbon fiber sphere that weighs 65 pounds. VR4 digital projectors operated by a bank of computer servers. It's pretty interesting. Okay. And, here we are again. We're going a little bit extreme on the time limit, but, I just didn't want to miss anything. And so we're going to, I know, it's crazy. All right. Let me zoom back out. Boom. Okay, so like I said, I think that, just stay reminded. Stay reminded that self-care is one of the best cares that you can do for yourself. Meditation is very healthy, for your mental peace and things like that. And I added in this self-care experience to not only have fun and go do things that you deserve to do in your life, but to also keep the joy and excitement that you obtain when you clean out yourself through meditation, through relaxing, detoxing, staying away from negativity and people like that. And so when you take that and put it hand in hand with self-care and whatever that self-care is, you can do you can have some great results, do some great things, have some great results. And so although we didn't get a chance to go on the inside, it's okay, it's fine, we chilling, we out here. It was still pretty informational, it was exciting. Got a chance to get some cool souvenirs, and I'm gonna still go and probably get something nice to eat. I will vlog that, but I think we're just gonna have too many episodes. I might change my mind and do it anyhow, but more than likely I probably won't. But if I do, you'll see another video clip. Comment, like, subscribe. Check me out on Instagram, TikTok, here on YouTube, obviously. 3 platforms: King Renaissance, here King Renaissance TV, King Renaissance Talents. Okay, 3 different type of channels, 3 different type of platforms. Okay, and yeah, I don't know, just hit me up if you have any questions, advice. Doesn't matter. Just hit me up if you like. Share this video if you like. If you feel like somebody would enjoy it. And I'll talk to you guys soon. King Renaissance. Until next time. All right.